right. No, that's not conference. Is it projector?
It's projector. That little tiny room in there is the conference.
Splendid. Yeah, this place could really use a lectern for this purpose, but I guess I'll go up here. Good evening. This is a talk I just recently gave at PostgreSconf about the type system in Postgres, which hardly anybody really knows fully in my experience. So my ambition is to teach everyone in the room something tonight. Postgres has the most powerful type system of any widely used database. And in this presentation, I'm first of all going to go through Postgres's built-in types and issues that people may have with them, particularly things that aren't surprisingly as well known as they should be. And then I'm going to talk about custom types. Oh, this was because I was at PostgreSconf. You know this attack? You remember this? This is like the worst hack I've ever heard of. The guy who found this is one of the Postgres committers. And as far as I'm concerned, there should be some sort of multi-million-dollar reward for someone who does something like this. Who knows what sort of civil, military, whatever thing he prevented. Okay, timestamp with time zone. Someone tells me, who's brave enough, offer to tell me what Postgres stores when you create a timestamp with time zone. Go on, don't be afraid. What you're thinking is it. Oh. So you're thinking it stores a timestamp and a time zone, right? That's what right there in the name. This is not, in fact, what it does. So let's say that we have the time zone set to right here, and I create a timestamp with time zone column in a table, and then I insert into, hang on just a sec, I want to be able to see, there we go. We insert and we get it back again, so it's all great, right? Here's what Postgres docs say. The internally stored value is just the timestamp you give it converted to UTC. It does not store the time zone. Right, it's converted to UTC. If you don't give it any time zone information, it assumes that the timestamp you gave it is in the current system time zone. Right, so it converts from that to UTC and stores that. So if you do this, right, insert something at UTC and retrieve it, you get that UTC converted to the current time zone. This can trip you up. Timestamps are also fun. Let's say I insert into my timestamp column something and I give it a time zone, +3. Right? But when I retrieve it, no. Wait, what did I do? Yes, it just completely ignores the time zone information that you give it. Right. The fix is to cast the string you're giving it to a timestamp TZ to force it to convert it using the time zone that you gave it. Right. Now, time with time zone. I can hear what you're thinking, but it's not true. Time with time zone actually does store a time zone along with the time, but it's kind of dumb. When you work with it, it converts time zones, but it ignores things like daylight saving time. So as far as I'm concerned, this is virtually useless. Money is another one. Here's what the docs say. You're storing a fixed fractional precision, which is what you want. The fractional precision is determined by the database's monetary setting. So if I say I'm using US money and I insert $1,000 into my table, I have $1,000 that I get back. But if now I change the monetary setting to a different place, I get very different results out. Something else to be careful. You've probably all heard the advice that you should always store strings in Postgres as text, but you may not know why. There's probably in the back of your mind something like a character, 10 or whatever. That's got to be useful for something, right? If I'm dealing with 10 character strings, that's okay, right? Here are the problems with it. So I cast a single character to a 10 character string, and you can see from the lines above it that it is in fact 10 characters long, except it isn't. Gets worse. What's happening is values of type character are padded with spaces to the specified width, stored and displayed that way, but trailing spaces are treated as semantically insignificant and are removed when converting to any other string type, but they are significant in character variant text values. Why, I hear you all crying in your relentless search for truth, would Postgres have this strange character type? Because it's actually written that it should be this way in the SQL standard. And the Postgres people try hard to make Postgres compatible with the SQL standards, the most SQL compatible database. I got some people on the Postgres email list to check my work for this presentation. If you want to see the discussion that we had, it's at that address. Too late. Enums. Enums, right? Anyone used enums in Postgres? They have a couple of advantages. Performance, and they simplify your SQL. But they also have some disadvantages. Performance. Why? Because they are always 4 bytes. The enum value is always 4 bytes. Even if it only has 3 possible values, it's going to take up 4 bytes in your table. Changing an enum involves DDL, which at a lot of places is going to involve a lot of bureaucracy and talking to DBAs and, running PRs plus past endless committees. The content of the enum is in a fixed order that can't be changed. The content is also in a fixed case that can't be changed. It is not localization friendly, and it's not portable to any other SQL dialect. Range types. Is anyone here unfamiliar with or never used range types? This is high on my list of underappreciated Postgres features. You create them like this. So this is for a range of integers. So you give it the bounds of the range, and then you indicate whether the ends of the range are inclusive or exclusive, which doesn't really matter that much for ints, but is more for floating point, timestamps, that sort of thing. So this range here is 3, 4, 5, 6, because the 7 is exclusive. In case you need to build one in code, there's another way of building one using a function, where you give it the 2 bounds and the ends as a string. Postgres also has multi-ranges. This is introduced in Postgres 14. I contributed to the documentation, and they sent me a lovely t-shirt with my name on it. So this contains 3, 4, 5, 6, 8. Postgres has every imaginable function that you might imagine on ranges. And if you've ever tried to work with ranges you've set up yourself as 2 values for each end, and you tried to do any of these sort of computations, it is surprisingly requires a bit of thinking because you have to deal with is it inclusive or exclusive bounds, and then if I'm trying to do whether two things overlap, I've got to write this quite long thing, right? Is this less than this one, but this one is greater than this one, and but you don't have to because it's all built in. Yes, you can also create your own ranges. This is a range of internet addresses. So now I can do this. And I can do, wait, is that? Yes, there we go. And I can do this. This is the overlaps. No, includes operator. So that's pretty good. Ranges have been in Postgres for a long time. Multi-ranges are since 14.
Okay, so including the INET range.
No, this is custom defined. It's not built in. There's an extension that does it if you want to download that. And as you see later, there might be a reason to use the extension. But you can just define them yourself. A particularly useful thing to be able to do with them is exclusion constraints. So if you have something like bookings for a tennis court or something and you want to make sure that none of your bookings overlap, you can create a exclusion constraint like this. I've copied this example from someone else. I probably would have made it deferred, not immediate, but that's great. Oh, yes. You'll find that there is a problem though, because given what we've done so far, this will actually perform quite slowly, even despite that this creates a gist index for you. The reason is that the indexing needs a metric, a distance relationship on the values that it's storing in order for it to arrange the index in a useful way. So what we need to do is give Postgres a distance function. So here we've written a distance function for two internet addresses. Did you know you could subtract them? Useful for this, if nothing else. So now we give, oh, thought I circled that one. We add, when we're declaring our type, we add this, and it'll all work at breakneck speed. You do still have this problem. These two ranges are logically equivalent, right? But as we've done, given what we've done so far, Postgres doesn't know that. There is a way to fix it. There's another argument you can pass when you're declaring the type, which is a canonicalization function. So you'll write a function that will sort of pick one of these representations and convert everything to it. But to write the canonicalization function, for some reason, it has to be done in C. Okay, composite types. Every programming language you use, other than MySQL and SQL Server, they're variants of SQL, let you define your own types, right? It would be silly to have a language where you couldn't define new types. And in fact, in Postgres, and I might do another presentation on this, there's a way to do it in SQLite, you can do it in DB2 and Oracle. You can define your own composite type that represents the structure of a row or record. So it's just a list of field names and their data types, much as you would declare something like a class in your average programming language. So here's an example in Postgres. Very straightforward. This in fact has the same structure as a table definition, except you can't have constraints. Note, by the way, you need to have this as word here. It's legal without it, but that's for defining types that are defined in C. Yes, sir.
This is for a column, correct? Not for a first page that entire row column similarly to.
I'll get to that. I'll get to that. Now I can create a table with a column of that type. Postgres's support for these custom types is full-fledged. You can do all the things with them you might imagine. So the way you write a value of one of these types is as a tuple, right? Just like you'd use for inserting a row into a table of that type, right? Like that. And here's how you would work with a nested value inside one of those composite types. Because SQL is terrible, you have to put parentheses around it in some cases where it might think it's a table name. Right, so I have to use parentheses up here, but I don't need to use them down here. I believe you could. So you could just make a policy of doing it everywhere, and that might actually indicate that you're dealing with a composite type. By the way, the font I'm using looks like that as a space, but it's not. Here is how you would do it if you want to indicate table field subfield, like that. And it pretty much works the way you would want it to, right? So I can do this, I can reach inside the composite value in my row and change the value, just like you'd like.
Second one required, because it might be a table name.
Yeah.
But the other side I figured out.
Yes, because you can't update another table with,
Makes sense.
yeah. I tested all these things, it works. Yeah, that's not a bad call, actually. We can also nest types, so I can create an address type, and then I can create a person type with an address inside it, and I can create a table with a field of person type, so now I've got a nested type in a column. Right. Here is how you would insert into that row is with nested tuples. Like I say, it all just works kind of the way you would expect. Here's how you reach into the inner tuple, and then, so the inner type, and then the person type, and there you go. So you can also write custom functions that work with these types, and again, it all just works as you would expect. So here I'm taking an address and pretty printing it. And then I can use it like this. And here's a neat trick. There's my PP function. That a lot of people don't know. If you have a function that takes one argument like this, you can also call it like this. Which is why, in case you've ever wondered, Postgres hasn't been in a hurry to add computed fields. A lot of databases, Postgres actually does have them now, but the results are stored, so they're not that useful. But you can sort of fake it pretty well. Yes, and then you can also define operators on your type. Multiplication, inclusion. Postgres is a long list of possible operators you can write. I won't dig into how to do this. It's surprisingly straightforward. You just write sort of functions that do the operator thing and declare them to be the operator. Now, here's another way of defining a type in Postgres. When you define a table, you also define a type with the same name and structure. That type is the type of a row of that table. That make sense? So when you're writing a query, you can actually refer to the whole row just by giving the name of the table in your where clause or whatever. Yeah. You can also do it the other way around. So if I have an inventory item type defined, I can create a table from that. But, right, of inventory item. But because you can't include the constraints in the type, there's a syntax for adding the constraints when you do this. Here's an example. I don't know if you know, but you can, yes, sir.
Were you insinuating that we could have a table of multiple custom types as an entire row and be able to reference that row by its name? You said inventory, but before that was the row that we built to mean that row.
I'm not quite sure I understand what you're asking. Within the query, if you use the name of the table, which you can do in the select clause, right? For example, you can give the table name dot star. So what you're actually doing there is referring to the row, the current row, and then applying the star operator to, which I'll get to again in a little minute. You can write a really great thing to do that I don't see used very often. We should do everything we can to simplify our SQL and make it more readable, right? Something you can do is write functions that take that whole row and then do something useful to it, like effectively compute a column, right? So then you'd be able to do the table name dot and the function you want to call. Does that make sense now?
Yeah, a little bit. I think my question is along the lines of create a custom type and so that we were able to create a name for the entire row, not for the table.
That generally, if you create the table, the type that gets defined has the same name. If you define the type first, you can create a table with a different name. By the way, in case if you think about it, you can create a table and then you can create another table with the same structure by saying create table of and the other table, because it picks up the type but not the constraints, and use it again. Although there's a better way to copy a table. Yes, so here we've got, so as I started to say, you can overload functions of Postgres, which means you can write multiple functions with the same name as long as they take different argument types. So here I define another PP function that takes a folks value, and actually inside of it is calling the other PP function. And that's fine. Right, and now I can do it here, and it's all good. So when you select one of these composite types from a table, you get a tuple, right? Or in this case, a nested tuple, right? Because we had a type inside a type. Okay? This allows us to see in a little more subtlety what the star operator does, because I can do this to break that row value, that tuple up. So star really means break the tuple up into separate columns.
Is there something going on with the quotes on this one? The double quotes around one main street?
I think that is, this is the output, not input. So this is how.
Escape quotes inside the quote marks?
I'm not sure.
Because you're in a quote.
Yeah, no, I know what you mean. I actually ran all this stuff. So this is how Postgres prints it out.
Like quoting the tuple that is the. Well, no, I think what it's doing is it's nesting the quote marks so that there's a whole set of languages, I don't remember which ones they are right now, where instead of being backslash to escape things, you double them, triple them.
Yes. Isn't it fun? They love SQL. So you may find yourself now complaining, well, this is fun, but it's not relational, right? This isn't, we want to be relational and virtuous. But in fact, everything I've shown you fits perfectly into the relational model. So Wikipedia says that each element in the table is a member of some data domain. It doesn't, the original definition of a relational database doesn't say anything about what types it stores. In fact, the original paper that wrote this envisioned that the database would have attached to it a full programming language, and you would be able to store any of the types from that programming language in the database. Further, An attribute is a name paired with a data type. Doesn't, again, say anything about what the name should look like. So in something like this, that is a perfectly good name for a field. However, before you go running off using composite types all over the place, because they are semantically, pretty good, right? There is an issue. Let's say I create a type toInt, which is 2 integers. And I create 2 tables. One of them has 2 integers and one has the toInt type in it. And I insert into both values equivalent, both tables equivalent values. When I get the size of the columns in the table with separate columns, it's 32 bytes. When I do it with the composite type, it's 53 bytes. That's quite a big difference. The reason this happens is the way composite types are currently implemented in Postgres. Even if all the fields inside the composite type are of fixed size, Postgres still treats the whole thing as of variable size, and in fact, I'm told, variable type. So that 21 extra bytes is size and type information for all of the fields. Yes?
How performant are those composite types, and are they used in practice so that you can actually address them with a language like Ruby in some way?
Ruby doesn't. I was just having a discussion on the Postgres Reddit about this today, actually. I don't know of any ORM that fully supports all of the type system, although apparently there's a JavaScript one that kind of looks like it might. Postgres will, Ruby will retrieve, Rails will retrieve arrays, which is another sort of custom type, but it won't work on, I think the tuples that you get back are strings, actually. Someone could write something that pulled them apart.
Are you aware of any mainstream usage of composite types like the PostGIS?
Oh, yes, PostGIS uses them. Although they are all or almost all of the C, defined in C type.
Is that for performance reasons, you know?
Yeah. Yeah.
Now, the other question was, how performant are these? Like if you're querying into a nested type, you had an example of something.name equals that's your where clause. Is that as performant as any other where clause because of how things are indexed internally, or?
It's a little bit slower because of the way Postgres treats it as being a variable type and size all the time. It's not massively so. And when I gave you that caveat about composite types, I didn't mean that to suggest you should never use them. Don't use them on very big, very heavily trafficked tables. But if you're doing something for a small business that doesn't have a lot of volume, or for smaller tables in your applications, they're great. Anything else? I had added a thing about domains to this talk, but it didn't copy over from my laptop to my... So I should briefly mention, you can define a domain in Postgres. Domain is just any type, and then you add constraints, not null, and check clauses to the definition. So it's a sort of like a subtype. What it means is that, let's say you have a 10-character product ID that you use all over the place in your application, in your database, and you want to check that it's 10 characters, that it matches some regular expression, that it's not null, a few things like that. You can define a domain, it's quite short and simple, and to do it, and then everywhere you use it, you can refer to the domain, and you don't have to remember to update all over the place if you want to change something. It's more self-documenting and simple. Yes, sir?
Maybe an answer to the string type problem around it. Or a string like that, and characters should never exist in an object already. It's an act or phone. You have allegations. If you use it as a string, that's where the string is where you have to validate everything. But if you create it as an object, then certificate as such, and it comes with all the validations. It sounds like that's a database layer version of that, where you're like, hey, look, these things, all these things, it comes back to errors without having.
Yeah, kind of. I mean, Postgres isn't object-oriented, so it's not an object, but it's a thing that wraps all, it does encapsulation, which is what you're after in that case. Yeah. Oh, the other thing I added was a slide where I went through all the types that Postgres has that aren't that well known, like internet addresses. If you've never done it, you should go and look at Postgres's types documentation. There's a lot of them, and they are all very thoroughly covered with all the functions and features you might need. Things like spans of time, right? 2 days, 3 hours, 7 minutes, 16 microseconds. You can have that as a type, and then there's math you can do with it. There's a bunch of things like that. All right.
Thanks, Dan.
I closed. Why is it still connected?
Likes the limelight.
There you go. As I said, there's a way of doing something similar in SQLite that's not obvious and may not be known to any of you.
All right. So as you will see on either the next slide or the slide after, there is no July meetup. I will say this several other times in several other places, but we will not be here on July 4th. Go do something else. But we will have a meetup later in July, once I'll talk about that in a second. But I am looking for speakers for the fall. So basically the entire last half of the year is wide open right now. So if you either have a talk you'd like to give, or even if you have thoughts on topics that you would like to see, you could do me a huge favor and post those in Slack, because inevitably when someone says, man, I really wish I could see a talk about X, someone will volunteer to give that talk. So we haven't seen that a ton historically, but it's never gone unanswered. So that's something to be aware of. SDRuby apparently takes requests. I'm sorry, what was that, Eric? Like any good DJ, we take requests. I will not play Freebird. So anyway, that's something that is out there. Lightning talks can be 5-10 minutes. Just be a gem you found that you thought was cool. There's lots of things you could talk about. And then our full-length talks are 30-ish minutes. Do I have any announcements?
My work by June is hiring a QA engineer, so you can connect me on LinkedIn or there. And if you do want to actually connect me on LinkedIn, actually say who you are and why, versus the amount of people that just want to connect and then say exactly why. I will not usually say something. So if you're interested, find me on LinkedIn. Check the group. I think I'm on the groups right now. Our meetup group.
You are.
And then on LinkedIn, I'll look for you. And it's entry level. That means job. Good job. It means it's outside the house. You gotta have some technical experience. It's only 5 years, right? Masters. Busy masters. You go, we're hiring what's that, and hiring for a long time. With a lot of positions. Position, we hired recently as low as 5 years of experience, as high as 30 years. So it's going to be years of experience. Some people, I've been seniors at other companies, but really you're in day and you can tell that's cool. You know, we want you to come work because you know you're still here out of time. And that's practice. You get those opportunities. But that is well.
Mud flat. What is mud flat?
We do not. We sell diesel books. We are a marketplace. Basically, the largest provider of book discounts for maintenance. So we did roughly every day $4 billion. Which is a lot. Right? A lot of money movement going through there. We don't take and our drivers get access to that power that we're able to negotiate for. We get 50 cents, $1 off a gallon. On the high side, you know, the average for them is
You're trucking.
that was also an app with phones that get the building basically enter information in an app. Where it started, now we have a integrated with Visa, bicycle money. So we have one Visa card credit coming up, another one from a different it started as helping those guys, and now it's expanding into help the cash flow.
So you guys are just like a platform connecting both sides, the buyers and the sellers.
Yeah, essentially, platform connecting buyers and sellers. We probably
All right. In July, probably in mid to late July, we will have a social of some kind. We'll probably get together. I'm gonna guess, just based on past experiences, that we'll get together at Ballast Point in Little Italy. Sarah, who's one of our co-organizers here, has a range at which she's willing to travel from downtown where she lives. And Ballast Point is a great place for this kind of meetup. So that's likely what will happen. Date is TBA, but we'll announce it on Meetup and we'll put it on our Slack channel. Speaking of which, if you are not part of the SDRuby Slack, this QR code probably will let you in. We got a permanent one recently, and it's been working very consistently for the last several months. But I don't know, I've been burned by that before, so.
Every time there's cost cutting in Salesforce, they just call Slack QR codes.
No, they went to a place where they timed out every 30 days for a while, and then enough people were like, "This is dumb. Please stop doing that." So then they went back to having them be permanent. Apparently.
You know, at this point, why not use Campfire? Is it Campfire or Fire? One? Campfire.
Well, one, we would have to host that, and SDRuby has no cash flow. And two, I already have Slack open, which is how we ended up with a Slack channel. And that's why no one's on the SDRuby IRC channel anymore. Right? Like, yeah. On Freenode, baby. You have to be OG crew to know about the IRC channel, because I think we stopped using it in like 2008.
You could resurrect it.
Yeah, it'll be just you and Trey, who runs the local Python group.
I just sort of throw out there, you have a Linode, probably run Campfire. No pressure.
Yeah.
I smell a
I'm not. I've been there, man. I've done that. All right, and that concludes SDRuby for tonight. A bunch of us will head over to Station, which is literally out this door and across the street. You can follow everybody else if you don't know how to get there. And thank you all very much for coming.